Namaste to all. Welcome to my channel MA Tuitions. I am Lita. The last class we were discussing about the cross multiplication method to find out the solutions of pair of linear equations. Today we are going to continue with the same exercise 3.5 and the second question. Here is your question number 2. For which value of a and b does the following pair of linear equations have an infinite number of solutions? And the pair of linear equations is given 2x plus 3y equal to 7 and a minus b into x plus a plus b into y equal 3a plus b minus 2. So we have already studied if you had given a pair of linear equations, if they have infinite number of solutions, some conditions should be followed. What was the condition? a1 by a2 equal to b1 by b2 equal to c1 by c2. So we can write if you have a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. If this pair of linear equations then and it has infinitely many solutions, we can write a1 by a2 equal b1 by b2 equal c1 by c2. Okay, so compare these two equations with the given equations. So we can write if this is the first equation and if this is the second equation, we have to change these two equations into another form. That means in this standard form, we can write 2x plus 3y minus 7 equal to 0 and a minus b into x plus a plus b into y minus 3a minus of 3a plus b minus 2 equal to 0. So we can write this as the first equation and this as the second equation. Okay. Now we can consider this a1, a2, b1, b2, c1, c2. Here a1 is 2, b1 is 3, c1 is negative 7. And here a2 is a minus b, b2 is a plus b and c2 is negative 3a plus b minus 2. We have the condition like this, a1 by a2 equal b1 by b2 equal c1 by c2, which implies a1 is 2, 2 by a minus b, a1 by a2. b1 is 3, 3 by b2 is a plus b. And c1 is negative 7 by c2 is negative 3a plus b minus 2. We can cancel the negative sign here. And we can take the first ratio and the last ratio and second ratio and the last ratio, or first and second and third as you wish, and you can find out the two equations in a and b, and from finding out the values of a and b from that equation we will get the answers. Okay, so we can take a2 by a minus b equal to 3 by a plus b. Just cross multiply 2 into a plus b equal to 3 into a minus b, or 2a plus 2b equal to 3 into a is 3a minus 3 into b is 3b. We can take the like terms into the one side. So 2b, this minus 3b will become plus 3b. When we are taking this to this side, this is 3a, and take this 2a to that side, you will get 5b equal to a. So a equal to 5b. This is your third equation. So take the second and third ratios, we will get 3 by a plus b equal to 7 by 3a plus b minus 2. Here also we want to cross multiply. Then you will get 3 into 3a plus b minus 2 equal to 7 into a plus b. So just open the brackets, you will get 9a plus 3b minus 6 equal to 7a plus 7b. Taking the like terms to the same side, you will get 9a minus 7a equal to, here 7b is there and 3b can be taken to that side, minus 3b, and this minus 6 will become plus 6. 9a minus 7a is 2a, 7 minus 3 is 4b, plus 6. We have already find out a relation between a and b. That means 5b equal to a. This was our third equation. So we can substitute this a equal to 5b in this one. So we will get 2 into, instead of this a we are using 5b equal to 4b plus 6. 2 into 5 is 10b equal to 4b plus 6. 10b minus 4b equal to 6. 10 minus 4 is 6. 6b equal to 6. So we can write b equal to 6 by 6, which is equal to 1. Since b equal to 1, we have find out that 5b equal to a. So 5 into 1, which is equal to 5. So a can be written as 5. So our values are a equal to 5 and b equal to 1. So the second sub-question in the second question, for which value of k will the following pair of linear equations have no solution? And two pair of linear equations are given, 3x plus y equal to 1 and 2k minus 1x plus k minus 1y equal to 2k plus 1. So in the second equation, one variable is given other than x, k. One constant is given, which is k. We have to find out the value of k since these two lines do not possess any solution. So we have studied three conditions, isn't it? If two pair of linear equations are having unique solution, means their coefficients a1 by a2 not equal to b1 by b2. And if they have infinitely many solutions, a1 by a2 equal to b1 by b2 equal to c1 by c2. And if they do not have any solution, we know that a1 by a2 equal to b1 by b2 not equal to c1 by c2, isn't it? So we can first write the condition a1 by a2 equal to b1 by b2 not equal to c1 by c2. So we have to write the reason, since these pair of linear equations do not have any solution. Okay, no solution is there. So first we have to compare these two lines of equations with the general form. So we can write 3x plus y equal to 1. We can take this 1 to this side. You will get 3x plus y minus 1 equal to 0. This is your first equation. And 2k minus 1 into x plus k minus 1 into y minus 2k plus 1 equal to 0. This is your second equation. Okay, compare this with a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. So here a1 is coefficient of x 3, b1 is coefficient of y which is 1, c1 is the constant term which is negative 1. Here a2 is coefficient of x which is 2k minus 1, b2 is coefficient of y which is k minus 1 and c2 is the constant negative 2k plus 1. So we know the condition, so we can take the first two ratios a1 by a2 equal to b1 by b2, which implies a1 is 3. 3 by 2k minus 1 equal to 1 by k minus 1. Cross multiply. 3 into k minus 1 equal 1 into 2k minus 1. This is 3 into k, 3k minus 3 into 1 is 3 equal to 2k minus 1. Take this 2k to this side and this negative 3 to that side. You will get 3k minus 2k equal to, this negative 3 will become 3 minus 1. So k equal to 2. So the value of k is 2. So third question of that exercise, solve the pair of linear equation by substitution and cross multiplication method. 8x plus 5y equal to 9 and 3x plus 2y equal to 4. So a pair of linear equation is given. You have to find out the solutions. That means you have to find out the values of x and y through cross multiplication method and also by substitution method. So first we will do the substitution method. For that we are taking these two equations as 1 and 2. So 8x plus 5y equal to 9. Okay, 8x plus 5y equal to 9. And we can write 8x is equal to 9 minus 5y, isn't it? We have to substitute any one of the variable into the other, isn't it? X equal to 9 minus 5y by 8. So this is our first equation. And what about the second one? 3x plus 2y equal to 4 is our second equation, isn't it? Put 1 into. So in this, the second equation, we have x and y, and the first equation only y is written in the form of x. X is written in the form of y. So we can substitute the value of x in the form of y into the second equation. So we are doing like this, 3 into, instead of x we are using 9 minus 5y by 8. Okay, 9 minus 5y by 8 plus 2y is there equal to 4. Now we can multiply. 3 into 9 is 27 minus 3 into 5 is 15y by 8 plus 2y equal to 4. Taking 8 to this side, you will get 27 minus 15y plus 8 into 2 is 16y by 8 equal to 4, which implies 27 minus 15 plus 16 is plus 1 plus y equal to, take this 8 to that side, you will get 4 into 8, which is 32. 27 plus y equal to 32, which implies y equal to 32 minus 27. So, which is 5. Y equal to 5. Now, we can find out x. How can you find out x? By substituting the value of y equal to 5 in the first equation. Put y equal to 5 in 1. So, you will get x equal 9 into 5 by 8. 9 minus 5 into 5 is 25. 9 minus 25 is negative 16 by 8. So you will get negative 16 by 8 is negative 2. So our values are x equal to negative 2 and y equal to 5. So this is our substitution method. Now we are going to find out the same solutions using cross multiplication method. To solve these linear equations using cross multiplication method, we have to change the pair of linear equations to standard form. That means ax plus by plus c equal to 0. So we are changing the two equations as 8x plus 5y minus 9 equal to 0. We have to change this constant to this side, okay? And also 3x plus 2y minus 4 equal to 0. These two are our equations, linear equations. Now we can find the values of a1, b1, c1 and a2, b2, c2. So here a1 is coefficient of x, which is 8, b1 is 5 and c1 is negative 9. We know. What about a2? a2 is 3, b2 is 2, c2 is negative 4. And we have studied the formula to find out, isn't it? Or the easy method or the formula, whatever you wish you can write. We can write b1, c1, a1 and b1. Okay. What about b2, c2, a2 and b2? Here you have to write x, here y, here 1. Then cross multiply. Isn't it? This is the method, cross multiplication method. So we can write x by b1 c2 minus b2 c1, b1 c2 minus b2 c1 equal y by c1 a2 minus c2 a1. Isn't it? Equal to 1 by a1 b2 minus a2 b1, a1 b2 minus a2 b1. This is our equation. So we can write x by b1 is 5, c2 is 5 into negative 4, 5 into negative 4 minus b2 is 2, 2 into negative 9, 2 into negative 9 equal y by c1 is negative 9, negative 9 into a2 is 3 minus c2 is negative 4 and a1 is 8 equal 1 by a1 b2 minus a2 b1, a1 8 into b2 2 minus a2 b1, a2 is 3, b1 is 5. So we can write x by, this is 5 in 84, negative 20, 18 negative positive, 2 and 9 is 18. This is y by 9 to 3 is 27, negative 27, minus into minus is plus, 8 into 4 is 32. 1 by 8 into 2 is 16, minus 3 into 5 is 15. So we can write x by negative 2, 20 minus 18 is 2, the larger has the negative sign, so we are substituting negative sign here. 32 minus 27 is 5, y by 5 equal to 1 by 16 minus 5 is 1. So we can write x by negative 2 equal to 5 by y by 5 equal to 1. We can take the first and third. We will get x by negative 2 equal to 1 or x equal to 1 into negative 2, or we can write x equal to negative 2. And what about the second and third? Y by 5 equal to 1, which means y equal to 1 into 5, that is y equal to 5. So we have got the same values as we have find out through the substitution method, x equal to negative 2 and 5, y equal to 5. So this is a solution for the linear equations given through substitution and cross multiplication method. So we have done second and third question in the exercise 3.5, the substitution method, cross multiplication method and all. Thank you so much for watching. We will continue the exercise 3.5 on the next class. Thank you so much.